Well, yeah, so I'm going to talk about best management practices, particularly more what we do in Northwest Ohio, but these are applicable all throughout the state and this particular area of the country. All right, first one, obviously, cover crops. Okay, pretty standard stuff. We've all seen pictures of the big radishes, 3 foot long, foot diameter almost. These things are pretty popular right now. Cereal rye is popular. You got the under ryegrass, that's popular. Things like that. This is a very common practice. Probably the most popular best management practice today. Okay, if you haven't noticed, all day yesterday there was something out there in the chapel that was about cover crops. Okay, and today I think is soil health. Okay, which all goes hand in hand. Okay, so it's very popular. It's got many potential benefits, and I say potential because a lot of this can't be quantified with any kind of numbers. Okay, but if you talk to the guys, Dave Brandt and people like that, they will guarantee you that there is benefits. So like I said, there probably are, but we can't really quantify them with numbers just yet. Typically, winter kill species aren't a species that we would consider very good in terms of water quality. Now, it still may hold some soil erosion issues, which is important, but typically when we talk about sucking up some of the nutrients through the water, they have to overwinter and grow into the spring a little bit. Okay, so things like oats and things like tillage radishes by themselves may not be the best water quality species, but combined together with other things, they can improve it quite a bit. It's a continuous practice. It's not a type of practice where you go and plant cover crops one year and that's it. You've done your job. Okay, you do it every year or every year that you can. Okay, so it's not like you're going to build a structure out there. You're not going to put in a tile. You're not going to do anything like that to where you put it in and it's done. You have to keep doing it to get the positive effects from it, right? This is probably my favorite bullet point, and I say that. I don't really agree with it, but it's going to get a bunch of people thinking of it. Did he really say that? Yes. Cover crops, if you exclude the soil health benefits, may be one of the most costly practices. And if you think of it like per acre dollars, think of 30 to 60 acres per year for the cover crops. I don't care what time frame you spend, that's going to add up quite a bit. Now, again, I said if you exclude the soil health benefits. Okay, I know there's a lot of you saying, well, yeah, what about this? What about that? Yes, that's all good, but again, until we can quantify those by actual numbers, we really don't know. I happen to believe that they do good, and it's not that costly. But those are things we have to consider when we start spending public dollars. Okay? Okay, then we get to 4R stuff. Okay, 4R. Right source, right rate, right time, right place. Pretty much this whole conference is about that. Okay, if you went to the manure stuff, if you went to the nutrient management stuff, okay, all those things were discussed. I'm not going to go into detail, but we all know that if you're not doing 4Rs, if you're just throwing fertilizer out there just because you think it's needed, you're wasting your money. Okay? So if you follow them, you could potentially, probably, save quite a bit of money in fertilizer saved. Okay? Again, if you do them the right way, you also aren't going to be losing as many from surface runoff through the tile, things like that. Okay? So they're also economically beneficial and they're very good for the environment policies. Okay? However, they do not address soil erosion or subsurface drainage water quality issues. Okay, they're just based on the fertilizer or the manure. Now, if you're comparing two situations where you're injecting it to whereas you're working it, that may be a difference in soil erosion practices. But in general, they are not the practices we use to address those issues. Okay, but they are a part of the overall solution. Okay, so 4R is good, both sides of the ways. Okay, that is one BMP. Okay, then we get to grass filter strips. We've all seen these things, particularly up in Northwest Ohio by our ditches. Okay, could be anywhere from 30 feet wide out to 100 foot wide. Okay, all this is a grass buffer strip between a woods, a ditch, or anything like that. Okay, could go on a property line, could go on any kind of type of waterway. And the idea is that these has the potential to filter out the water, not filter it out, but as soon as the water goes across it, it can spread out, slow down, and drop out sediment. Okay, so they have potential to catch sediment. They do not adequately remove dissolved nutrients. So any nutrients that are dissolved in the water is going to stay with the water, and it's going to flow off into the ditch. Okay, but they do good things for the sediment erosion, and they also have some wildlife benefits. Okay, the downside is obviously you're giving up some ground to put that in. If you're in a program through FSA, you may get cost shared anywhere from, say, $150 to $250 per acre. There are those possibilities out there as well. Okay, then we get to grass waterways, which are like buffer strips, but in a strategic location. Okay, this is a very common practice in this county, and basically any of the counties that surround or are outside the Black Swamp area are areas where you're going to have a lot of grass waterways. Now we can do these inside the Black Swamp area, just not as common. Okay, the idea is that anywhere in a field where you have channelized flow that's causing a huge gully erosion in the field, what we're going to do is we're going to come in, we're going to shape that dirt, plant some grass where it's easy to cross, and where it's designed so that the flow doesn't erode any of the dirt. Okay, this is probably, in terms of the whole state as a whole, this is the most common best management practice that the Soil and Water District technicians do on a day-to-day basis. Okay, if you just look at the whole state, that is probably the number one thing that we get involved in as technicians. Okay. Okay, I went through some of that stuff. Again, it does not remove the dissolved nutrients. It could take out some nitrates if it had the ability to use it when it was growing, but for the most part, the dissolved phosphorus just stays with the water and moves downstream. Okay, but it does a very good job of taking out the soil erosion issues. Okay, then we got these newer things, and they're not really new. These have been around for 15, 20 years, and I stole these slides from some OSU people, but the two-stage ditch, and there's, what, 3 of them straight east of here, Jessica, now, that are in Hardin County. So they're starting to catch on a little bit more, and the idea is typically if you go to Henry County or the typical counties in western Ohio, you have the trapezoidal ditch. Okay, you have the straight sides coming down to a flat bottom. Very efficient for taking the water away fast, just not over time. Over time they can fail for different reasons. Okay, the idea of a two-stage ditch is to keep those banks much more stabilized, and it may potentially even increase. Okay, so again, all we're going to do is we're going to pull them banks back a little bit so that we have some extra room on the side so that the small flows will go through the inset channel, and it will properly take out the sediment, and all the large flows, 10-year, 25-year flows, will go on the floodplains on the side and not take out our banks. Okay, so they're much better a stability option for a ditch than a typical trapezoidal. Okay. Typically they have a wider top width. Well, not typically. Always they have a wider top width. Okay. So that is one thing that you'd have to consider, that if you're putting a two-stage ditch, you may have to give up some ground. In certain situations, maybe not so much. Okay. But that is something that would have to be considered on a two-stage ditch. Again, they allow for a more stable channel. They may increase the drainage capacity, and I say that because you have a wider cross-section, a bigger cross-section. But if your downstream capacity is what's limiting your flow, then it may not increase the capacity at all. But it just depends on the situation. It can reduce the nitrate losses with all the vegetation growing in the banks themselves. Can take up the nitrate. Okay. Again, it's more expensive, obviously, because you're moving more dirt than the typical trapezoidal channel, but that's the upfront costs. The idea is that you won't have to come in every 2 or 3 years and dip that ditch out because it's more stabilized. Okay. So hopefully, some of these situations we can get a two-stage ditch where, yeah, it might be more expensive to build up front, but since you're not going in and dipping out every 2 or 3 years, over time it pays off for itself. Okay. Okay. Then we have wetlands. These are very common in northwest Ohio. Okay. Like I said before, the Great Black Swamp used to be a big wetland. Okay. The whole area of northwest Ohio used to be all filled with these things. The idea is an entrapment mechanism. All the water that flows to them, it catches, and it slows it down. The sediment can fall out of it if there's any of it in it. All the vegetation can take up the nutrients, and the idea is that it'll just help clean up the water just a little bit. Okay. Again, it does reduce both sediment dissolved nutrients. It does have wildlife benefits. Okay, ducks, things like salamanders, things like that, things that like water. Okay, it has very good habitat benefits for different wildlife, which is why some of the cost share programs can be supplemented with things from like Ducks Unlimited, might kick in a little bit, Pheasants Forever might kick in a little bit because they provide such good habitat. Okay, it does take a significant amount of land out of production. Again, that wasn't a small wetland. You know, that was 5 acres up in Defiance County. Okay, so that is something else that would have to be considered with this best management practice if you're okay with that. The thing we found, we built a couple wetlands on our farm. Okay, the thing we found is that particularly the grandkids have fun going out there looking at the animals, and that is something that if you got kids, grandkids are into different things like wildlife, it's a good option for that for educational reasons. Okay. Again, it can be expensive to construct, but it also can be expensive to maintain. If you build a wetland that has a dike on it to where you're stacking up dirt that backs up water, that can be expensive to build, but the other side of that is you have to maintain it. Okay, you can't just let it go and let trees and things grow up on top of it. Otherwise, it'll fail eventually. You have to keep it mowed. You have to keep the muskrats out of it and different things like that. Okay, but these are things we get into quite a bit. We've done quite a few in Seneca County. I know Ottawa County does quite a bit up in northwest Ohio. And there's several over in eastern Ohio as well that we do. Okay, then we get to the big one. Okay, this is kind of the hot item right now. Okay, anything manure storage. As most of you are aware, we have Senate Bill 1 laws that passed, a year and a half ago that just came into effect a year ago. Okay? Because of that, farmers can no longer apply manure on frozen or snow-covered ground. Well, if they can't do that anymore, they have to store it over that time period when it is frozen or snow-covered. So now everyone wants to have some sort of manure storage. Okay, this could be a dry stack structure where we just build concrete walls and we put a roof over top of it where they put all the pen pack. Okay, could be a pond if you have a dairy or a hog operation, or you have any kind of lot water running off. Could be a pond where we collect that. Okay. Again, these are used to hold the manure until the time is right to apply. In the past, we haven't always had the capacity to hold the manure for the right time, so we might be applying at the wrong time of the year or in different conditions that aren't very adequate to applying. Okay? So this helps us meet the right time part of the 4 R's for manure specifically. Can be expensive to construct, particularly dry stack structures. The figure that's always thrown out there is $500 to $1,000 per cow. Now, I'm not saying that sticks true to every situation, but that's a good idea of how expensive these things can be for a farmer to invest in. Think if you had an animal. Would you be willing to have, if you had 20 animals, to invest $20,000 in something that doesn't pay back? Okay? That is the decision-making that goes through each one of these guys' farms when they come to their place. Now, I will say I do quite a bit of these. In the last few years, up in northwest Ohio, we've installed about 50 dry stack structures and maybe 15 or so holding ponds. There's two reasons why you would see me on your farm if you have livestock. The first one is because you asked me to be there. The second one, you didn't. Okay? So, in particular, Senate Bill 1 or any type of pollution abatement, if you have issues to where you had a spill of manure into the stream and someone reported you, we'd have to come out and do an I&E on your site. And if we found that you didn't have manure storage, we would offer help or possibly assistance to help you fix that issue. Okay? So again, these are big right now in northwest Ohio, and you're going to see these going everywhere for the next few years. Okay? We've got quite a few on file right now. This is just an example of a holding pond we did in Hancock County. This was a good situation where the guy had a feed lot that it was too big to put under roof, but he still had a lot of runoff coming up from all the rain, so we had to collect the rain. So we poured some concrete, and it all came through this, can't really see it there, but it's like a concrete chute channel. It all got sent to that location that goes into the pond. It provides him with 12 months worth of storage of that, then he goes and applies it on land. Okay? Worked out very well for this gentleman. He also built a dry stack structure just to the right of it. So what he does is he pushes all his pen pack stuff across the concrete. All the juices, liquids flow down into the pond, and the storage for the solid stuff goes up into the dry stack. Okay, so this was a case where it worked out very well for this gentleman. And this is just an example of things we've done all over northwest Ohio, and not just northwest Ohio, but all over the state and all over this area of the country. Okay. Okay, this is what I'm talking about, a typical dry stack structure. Now, it doesn't look so dry in this picture. This was 2014, I think. They had really blowing rain. They got a few inches, and it's just one of those rains where it gets everywhere, and so that's why it's so wet in there. But you'll also see he's got some feeder pans in there. Okay, well, why is that? This is built for manure, right? We do allow, and have allowed in the past, that if you don't need the storage at the moment, because he just went and spread it. This was in somewhere around November. He just went and spread when it was fit, okay, he's got all that extra room and he can expand a little bit. Now what he'll do, you can see in the back, he's got some piles of manure that are already stacked up. He's going to start bringing it out this way, and then as it fills up, he's going to push those pans out, okay? And this works very well for this guy. He loves it. And I have to say that even though these are very expensive to build for people, I have never heard anyone come back to me and say, boy, that wasn't good. I shouldn't have done that. They all say something to the line of, well, I didn't know how I did it before. This is just the greatest thing in the world. I can just keep it in there until it's fit to spread, okay? Every one of them's happy after the fact. Before the fact, we may have some issues, but after the fact, these have been very good for these particular livestock producers.
Why so tall? And not the concrete, why so tall? Why such a distance between the roof, the eave of the roof and the concrete?
So for what this is, this was a standard design through the specs of NRCS. They have a standard post height of 10 feet, okay, that can go up to 14 feet if required. And the thinking of why so high, not necessarily the concrete high, it depends on what he's stacking with. If he has a type of bedding and manure combination to where he can stack up to 10 feet high and he's got the equipment to do it, that would make his whole structure and whole dollar project smaller. And that was the case of this guy, okay? So yes, there are some shorter than that. That's the tallest concrete walls we do for that. That's 6-foot walls, okay? But this guy had the ability to stack it up to 10 feet high, okay? Good question. Okay, then we get into the solid separation of all the manure. Okay, this was a project we did in Wyandotte County. This is a fairly good-sized dairy, and he beds with sand. And sand's great for bedding. It's just it stays with the manure and it eats up equipment. Anytime it goes through a pump, it eats up that pump equipment. Okay, it's very abrasive. So the idea here, and it's expensive too. To get any kind of sand in there is expensive as bedding. It might not be expensive to bale your own straw or things like that, but it is a cost that he's got to go through. Okay, so the idea on this one is to send the flume water after you push all the manure to the flume. It comes out at the top left there, and it flows down on a specific slope and a specific speed. And at that speed, the sand will settle out, but the water and manure will just keep going down the line into the manure storage. And with this system, you can typically get, I tell guys to plan on around 70% sand recovery. Okay. So that's 70% less sand he would have to buy every week, okay? And this worked out very good for this individual. But it doesn't have to be a sand lane. It can be settling basin, which aren't as efficient as a sand lane, or it can be a mechanical separator, something like a screw press or something like that. Those are a lot more efficient, okay? Again, but it can be used for bedding, or it could be for a guy to separate solids from his liquids, because that's how he's got his handling equipment. He might be set up for some sort of irrigation system for his liquids, so he's got to get the solids out of it. And then in that case, he can take the solids that are then separated and transport them at a further distance because they have a higher nutrient content, okay? So it just depends on what you're after. We do have the ability to separate the two, okay? Again, that is particularly the three that I mentioned, the sand lane, the settling basin, and the separator. They do require a precise design to be able to tell what the grade is, how much power should be applied to it, and how often it should be run, okay? So this is something you would go through NRCS to do. I don't know, how am I doing on time, Jocelyn? What's that? Okay. I'm not done. Okay. Saturated buffer. This is a fairly new one. This is used in with sort of drainage water management kind of theory. But this is an idea where you take the flow from a tile and as it goes through the tile, it's then diverted into a separate tile that allows it to filter back into the soil, which is kind of difficult to understand because you use tile to collect all the water from the soil, transport it. Now you're going to use a tile to disperse it in the soil. And what you do is when you disperse that water back into the soil, the idea is that it'll filter through before it gets to a ditch and maybe take out some of the dissolved nutrients, okay? Fairly new practice, still being researched. Can be used with drainage water management or wood chip bioreactors, which I'll go over here in a second. And it may be limited to very specific areas, particularly the types of soils. Is very important on that practice. Okay, this is the type of structure we use. I know it's kind of hard to see. I don't have a pointer, but there's 3 chambers. The first chamber is used for the controlled drainage of the field. Then as it flows over to that one, it goes into the middle chamber, which then directs it out to the tile, which filters to the soil. And if he gets a really heavy rainstorm where he just needs more drainage, it'll flow over that third third set of boards, okay? Okay, and that's too hard to see. I'm not going to go through that. That just shows all the main layouts we had. That's kind of hard to see. All right, so then we have the bioreactors, okay? And particularly, I mean the wood chip bioreactors. These operate similar to controlled drainage, or not controlled drainage, but similar to the saturated buffer when they take the flow water from a tile and put it through a bed of wood chips. And the idea is to get the time right to where the water's in there just long enough to where it's able to react with the different microbes in there that will take the nitrate from the water and convert it to nitrogen gas, okay? And in some of the areas where they've been studying these things, they've had very good reduction of total nitrogen going through the water, okay? It does not take out any dissolved phosphorus, okay? The microbes don't feed on the phosphorus. So if that's something you want to do with this practice, that is where you would have to add on like a phosphorus filter. They talked about earlier this morning, you could put on like a septic tank size thing with some slag in it, and it would go through there and take out the dissolved phosphorus. But that is something you would have to do in addition to the wood chips, okay? Again, it can be used with controlled drainage. If you use a structure on this to control all the water going through it, then that structure can also be used to control drainage in the field as well. Okay? It might take some land out of production, but it's not going to be as big as, say, a filter strip. Okay, this is a slide or a depiction of what a bioreactor works like. You can see the water coming in with the red. That's the dirty water. It gets sent through the wood chips. Okay, as it goes through, it's there for a certain time, maybe like 4 hours. And as it's there, some of the microbes are going to take out the nitrates of the water. Okay, and once it gets to the end, it's going to come back to the beginning, then flow out to the ditch. Okay, that's the idea of a bioreactor. Where'd I go? Okay. All right, then we have water quality inlets, or what I call blind inlets. Okay, these are used to replace open inlets. Open inlets are anything that takes water from the surface and takes it straight to the tile without going through any kind of filter. Okay, particularly on the bottom, you can see this orange Hickenbottom. We see those everywhere in Northwest Ohio. There's potholes everywhere up here, right? And those have really been the best practice we've had to get that water to go somewhere else in the field, right? So it doesn't stay there in pond, okay? Those do a very good job of taking the water and put it into the tile, but they take everything else that was with that water. They take debris, they take soil, they take anything else that was inside that water and put it straight to the tile, goes straight to the ditch, goes straight to Lake Erie, okay? So while they're good for drainage, they're not so good for the environment. The idea is to replace them with a blind inlet, which is the same idea to where you take the water faster to a tile, but you just force it to go through some sort of sand filter. As it goes through it can take out some of the sediment or debris that was with it, okay? It does require design calculations, so they got to be sized at a certain size, depending on your watershed. And again, it takes out the sediment, and in particular, phosphorus that's with that sediment, okay? It may also take out some dissolved P. They've been experimenting with some different filters. Instead of sand, they've used something like iron slag. They've tried gypsum. They've tried expanded shale clay substrate that also works very well. So they are experimenting with it. Again, they're still testing on these over in Indiana, and we hope they give us some more information. We have put several in with sand up in Northwest Ohio. I think we're up to about 30 so far. It does allow farm equipment to pass right over. Now, on our farm, we have a field that has about 13 of these in, and it's not a very big field. It's only about 30 acres. Okay, so you can imagine take a 16-row corn planter. You're starting to play slalom with those things going in and out, right? It's not very fun going around the orange Hickenbottom. So the idea for us was to take them out, but still have a water quality benefit, and we can just go straight over them now. Okay. Typically, it's always going to be more expensive than an open inlet. Okay, and it does require maintenance. It's full of sand. That sand could get mixed with the soil. Something could happen. You may have to come in and replace it. Okay. Now, something that's similar to those orange Hickenbottoms is a tile blowout. Okay, big holes in the ground. We've all seen that go straight to a tile. Those operate the same way as an open inlet. That water gets out of there fast if it's ponded. Okay, it might not upstream of there because it's broken down, but it goes down to the tile, and all the dirt around it gets sucked in. That's why you have these big holes in fields. Okay, so the idea is to help fix those blowouts just like you would any other open inlet, and put dirt over top it and fix it, okay? Okay, here's some quick pictures. Okay, this is one of our fields up there. That's the before with the orange Hickenbottom. That's during the process. We dug the hole, we put some number 4 stone underneath of it, then we put the collection pipe. That's just standard sewer pipe with half-inch holes in it, and we sloped it down to the bottom to the outlet. Okay, then we covered it up with number 4 stone. And on top of that number 4 stone, we put a non-woven geotextile. It's sort of like the fuzzy geotextile stuff water goes through very fast. Then on top of that, we put the sand. Okay, and it's typically about 1 foot to 1.5 foot of sand. That's what it looks like when it's done. Okay, that's what it looks like after 5 inches of rain, and we planted corn right into it. So again, we didn't have to avoid the Hickenbottom. We just went right through it, and it still drains pretty good. Now you can see the corn's a little bit less. We didn't put fertilizer on it, obviously, but it's still not going to grow as good as the corn around it. But we didn't have to swing that planter out that might cause issues with the equipment. Okay, when you start turning planters, that's when things break, right? Okay, then there's drainage water management. Now, I'm not going to hit on this too much. Lindsay hit on this earlier this morning. But again, these are very common up in Northwest Ohio now. Through our programs, we put in some around 1,000 up in Northwest Ohio. And they're very common. People are starting to accept them more often. And the idea is just to hold back the water, okay? You're just basically taking the outlet and you're moving it up and down, okay? That box structure gives you the ability to move it up and put it down as you see fit, okay? Very efficient on flat areas. I'm talking Henry County. I'm talking Paulding County, okay? Fulton, Defiance, Paulding, things like that. Those are very flat in the little black swamp. Some structures we can control over 80 acres up there. Very cost efficient when you're talking that big of an area, okay? Particularly this area right here, we maybe only control 15 acres maybe, just because we have so much slope here, all right? It does not require many supplies or maintenance, okay? When we build these things, they're pretty simple. We just have to have so much solid pipe, put the structure right in the middle, fill it back in, okay? Some maintenance is required. You have to grease the boards, and you have to make sure the boards go up and down when they're supposed to. But that's it, okay? It can reduce nitrogen and phosphorus losses. Okay, we heard Lindsay's talk this morning, so I'm not going to go over it, but it is good, very good on water quality, okay? Can increase yield in certain years. If you get the rains at the right time, or if you wouldn't have at the wrong time, it can increase yields. Most years you might not see that, but in certain years you might really see it, okay? So I won't get into that too much. Okay, I'll go over some of these quick pictures before I get over here. This is an agri-drain structure. This is an ADS structure. This is a stainless steel structure that they were making out of Henry County up north. This is an this is a Haviland structure based out of Paulding County. Probably one of my more favorite of the newer ones. There's an anti-seep collar going on top of the pipe. We have to stop the preferential flow. There's a plastic anti-seep collar that's built in Indiana. Okay, you can see the difference, how big of an area you have to dig out on that. That's what they look like when they're holding back water. Okay, they don't plug the tile. They just hold it back until it goes to a certain elevation, then it starts draining out like natural. Okay, those are just some boards, different boards pictures, but what we got here. That's probably my favorite. That's a concrete structure. Okay, that's made by a guy that thought he could out-compete the plastic guys, the stainless steel guys, and all the rest. And it's in the ground, and it works good. The installation was not easy, I can tell you that. So he even thought he could do an anti-seep collar out of concrete, and he did. So take-home points, just real quick. Look, if you're not spending a day each year with your Soil and Water Conservation District or with NRCS, then you're probably not doing yourself enough justice on your farm as far as best management practices are concerned. Sit down with them. They can really help you out if you have issues. They can get you through most of this stuff, okay?